Friends, welcome to Bank Exam Cafe, and in today's episode we are going to discuss question number 3, question number 4 and question number 5 from chapter 7, Triangles of exercise 7.1. Friends, before starting the discussion of question number 3, 4 and 5 from exercise 7.1, I would request you to join our Telegram channel. The link of the Telegram channel is provided in the description box, where I regularly put the MCQ questions for term 1 from the subject Science and Mathematics. So first, join the Telegram channel and do not forget to subscribe if you have not yet subscribed the channel, and try to share the videos with your friends so that they too will get benefited from it. Now let us see the first question, that is question number 3 from exercise 7.1. The question is that AD and BC are equal perpendiculars. This is the AD is a perpendicular on AB, as well as BC, this is the BC is perpendicular on AB. It means that AD and BC both are perpendiculars on the AB, and we know that the perpendiculars drawn on the same line are always parallel, so we can say that AD and BC are parallel also. Then this thing is not given to you, but when it is given that this AD and BC both are perpendicular to AB, then these two are parallel lines. That is not given, but it is hidden. And so also it is given perpendicular to line AB and show that CD bisects AB. We have to show that this CD, this is the CD that bisects AB. It means we have to show that AO is equal to OB. AO is equal to OB. These two line segments are equal, that we have to show, and if these two line segments are equal, it means that DC, this line segment, bisects the AB. Now let us see how to prove this. Now here first we will write the given things. That what are the given things? The given things are AD is perpendicular to AB, AD is perpendicular to AB, and also it is given that BC is perpendicular to AB. Correct? AD, this is perpendicular to AB, and BC is also perpendicular to AB. And now we will try to prove that these two triangles are congruent first. And what we have to prove? To prove that we will prove CD bisects AB. CD bisects AB. This we have to prove. And now the proof will be what? First we will prove that these two triangles are congruent. So we will write that in triangle AOD and triangle BOC, in these two triangles we have AOD, this angle AOD, and angle BOC, these two angles are equal because these two angles are vertically opposite angles. So we can write that angle AOD, that is equal to angle BOC. Reason is what? It is vertically opposite angles. We know that vertically opposite angles are always equal. Now the second thing is that angle DAO, this angle, and angle CBO, this angle, these two angles are of the measure of 90 degree because BC is perpendicular and DE is perpendicular, and therefore this angle and this angle, these two angles are of the measure of 90 degree. So second thing will be that what? Angle DAO, that is equal to angle CBO, reason which is equal to 90 degree, that is given. Okay, now the third thing we have to prove that AD is equal to BC is given, AD is equal to BC. What is given here? AD and BC are equal perpendicular. So here you will have to write in the given also that AD is equal to BC. So AD is equal to BC. This is also given. AD is equal to BC. That is given. Now see here. What is that? Here this angle and this angle is equal. This angle and this angle is equal, and this BC and AD are equal, and therefore by AAS rule these two triangles are congruent, and therefore triangle AOD that is equal to triangle BOC, reason the AAS criteria. AAS rule or AAS criteria. And since these two triangles are congruent, their corresponding parts are also equal, and therefore AO is equal to OB, and therefore AO is equal to OB. The reason is what? Corresponding parts of the congruent triangle. Now friends, here we have proved that AO is equal to OB. If in the exam it is asked that prove that this angle is equal to this angle, it is very simple. Again, corresponding parts of the congruent triangle, but the very simple way is that since CB and DA are the perpendiculars on same line AB, these two are the parallels and this will be the transversal, and therefore this angle and this angle will also be equal. Correct? Now let us move to the question number 4. Next question. Here L and M are two parallel lines intersected by another pair of parallel lines P and Q. Here what is given that this is L and M. These two are the parallel lines. L and M are the parallel lines, and P and Q are is the another set of parallel lines. Both intersect each other. Correct? Both intersect each other, and we have to show that triangle ABC, this triangle ABC I denote by 1, and triangle CDA, this triangle I denote by 2. So triangle 1 and triangle 2 are the congruent triangles that we have to prove. So first we will write the given. In given we will write that L is equal to L parallel to M. Also it is given that P is parallel to Q. Okay, then what we have to prove? To prove that we have to prove that triangle ABC is congruent to triangle CDA. Triangle ABC is congruent to triangle CDA, that we have to prove. Now the proof. How we will prove? We will prove that these two triangles are congruent because the other things are given. These two are parallel. These two are parallel. Correct? And therefore, since L and M are parallel, this AC will be the transversal, and therefore this angle and this angle, these two angles are the alternate interior angles, and therefore these alternate interior angles are always equal. So here we will write that angle BCA is equal to angle DAC. Reason is given, or we can say it will be more clear that alternate interior angles. Alternate interior angles. So these two are the alternate interior angles. Then the next is BAC. Similarly, this angle and angle DCA, this angle, these two angles are denoted by another color. This angle and this angle, these two angles are also alternate interior angles, and therefore because these two lines are parallel and this is a transversal, this forms a Z shape, and therefore this angle and these angles are the alternate interior angles, and therefore these two are also equal. So angle BAC, that is equal to angle DCA CA. Again the reason will be alternate interior angles. And now here we know that this AC, correct, and CA, this line segment is common to both the triangles 1 and 2. Therefore AC is equal to CA. AC is equal to CA. Reason is common. It means both is same to both the triangle. This is the side of triangle 1 as well as the triangle 2, and therefore AC and CA will be equal. So here we have proved that these two parts of these three pairs of these two triangles are equal, and therefore we can say that triangle ABC is congruent to triangle CDA. What will be the reason for that? This angle and this angle is equal, this angle and this angle is equal, and this side is common, and therefore by ASA rule these two triangles are congruent, and therefore triangle ABC is congruent to triangle CDA. Reason ASA rule, and that only we have to prove. Okay, and hence we have proved that these two triangles are congruent by ASA rule. Now move to the fifth question of the exercise. Now it is given that line L is a bisector of angle A. Line L, this is a bisector of angle A. It means what? This part of the angle and this part of the angles are equal. This is given to us. Now BP and BQ are perpendiculars. BP and BQ. This BP is perpendicular to this AP and BQ is perpendicular to AQ. This is also given. So this angle and this angle are of the measure of 90 degree, and it is given that to the arms of A show that triangle APB and triangle AQB are congruent. This triangle AQB first and this triangle APB, this is the second. These two triangles are congruent, that we have to show, and then we have to show that BP is equal to BQ. This is BP is equal to BQ, or B is equidistant from the arms of angle A. Now let us prove that. Then in triangle we will say that triangle APB in triangle APB and in triangle AQB and triangle AQB, what we have, that triangle angle APB, that is equal to angle AQB. Reason each are 90 degree, that is given. Correct? Because this BQ is perpendicular to this arm and BP is perpendicular to this arm, and therefore these both are of the measure of 90 degree. Now this is L is bisector of this angle, therefore this part and this part of the angle will be equal. So we can write that angle PAB, correct? PAB means this angle, and QAB means this angle, which is equal to angle QAB, because this is also given. Okay, because this L is bisector of angle A, or you can write L is bisector of angle A. Okay, then there's another thing, that AB is equal to AB. AB is equal to AB because both are common to the triangle 1 as well as triangle 2. So this AB is a side of triangle 1 as well as triangle 2, and therefore it is common, and so it is equal, and therefore triangle APB, that is equal to triangle AQB. The reason is what? AAS rule. AAS rule, and by AAS rule these two triangles are congruent, and since the two triangles are congruent, their corresponding parts will also be equal, and so we can say that if BP is equal to BQ, BP is equal to BQ, because of the corresponding parts of the congruent triangle. And since BP is equal to BQ, that is B is equidistant from this and this side, because this is the perpendicular and this is the perpendicular. And so here we have proved that the triangle APB and triangle AQB are congruent and BP is equal to BQ. Now friends, I hope you must have enjoyed this video. If yes, please like the video, share it with your friends, and do not forget to subscribe the channel. Thank you very much for watching this video.